Assalamualaikum and hello. Now we have case 3 for solubility in water, where I need to arrange and explain based on 4 structures here in descending order. So how am I going to start for this part? We are going to take a look one by one. So let's see from here, we got P. So P, as you see, it has benzene ring attached directly to COOH group. So automatically you can know that P is aromatic. So the size of benzene ring here is very bulky or very large that can hinder the solubility of P in water. So you can conclude that P has the lowest solubility in water because aromatic carboxylic acid usually has the lowest solubility compared to aliphatic. So I'm going to write down a bit notes here about bulky size of aromatic ring. Next one, we go to structure Q. So structure Q, you have one carboxyl group, and structure R, you also got one carboxyl group. So what will happen here, we cannot compare between both of them, Q and R, based on carboxyl group. So what we're going to compare is based on their molecular weight. So you can see that Q has 5 carbon atoms while R has 4 carbon atoms. So you can conclude from here, based on these two comparisons of structures, R has higher solubility compared to Q because this one has smaller alkyl group, contributes to smaller hydrophobic area. Next one, we got structure S with 2 carboxyl groups in the structure. So automatically you can conclude this one as the highest solubility because S can form more hydrogen bonding than the other 3 structures. So now I'm going to arrange my structures in descending order starting from the highest solubility, which is S. So S is greater than. The next one, we are going to focus between 2 aliphatic carboxylic acid. We got the highest one between R and Q is R. So R greater than Q. And the last one, for the lowest solubility, the aromatic carboxylic acid itself, which is structure P. So this is my arrangement. I'm going to explain based on this arrangement. Let's focus one by one. We have first paragraph between S and R. So S is dicarboxylic acid while R is aliphatic carboxylic acid with 1 carboxyl group. So what we're going to do, we are going to compare based on number of carboxyl groups. So I'm going to choose as my subject. So I will write it down as S has more carboxyl group than R. So that is the first point. And the second point, I can write it down as S can form more hydrogen bonding with water molecules than R. So please emphasize based on these two statements about term more here, because we are comparing based on their number of carboxyl groups. Next one, the last point, you have to write it down as S has higher solubility in water than R. So settle for the first paragraph between S and R. Let's go to the next paragraph between R and Q. So R and Q, we are going to compare based on their molecular weight. So I'm going to choose my subject, which will be R. So the first point, I'm going to tell about the size of molecular weight. So this one will be my first point. And the second point, you can tell as R has smaller alkyl groups than Q, and this contributes to smaller hydrophobic area. And the last point, you have to tell about which one has the higher solubility. So in our case, R has higher solubility than Q in water. So settle for the second paragraph. Now we are going to continue for the last paragraph between structure Q and P. So I'm going to choose my aromatic carboxylic acid P as my subject because I want to show you how you want to explain based on correct sentence for this part. So we are going to choose P as our subject. So the first point, you have to talk about their molecular weight, because both of these we are going to compare based on their alkyl group. So that's why the factor right now still the same, molecular weight. So I'm going to start with P as my subject. So P has bigger molecular weight than Q. So the next point, you can say that from here, P has bigger alkyl group, in this case, which is more bulkier. So this one, bulkier, is the term that I'm referring to the size of aromatic ring, and continue with that contributes to larger hydrophobic area than Q. So that is the second point. And now we are going to continue with the last point. You have to tell about P has lower solubility than Q in water. So settle for the third and last paragraph. So this is how you want to explain based on 4 different structures of carboxylic acid based on case 3. So I hope all of you understand now about the technique and how to describe the solubility of carboxylic acid, no matter how the structures you got in the question. So that's it for this video. I'll see you in the next one. Thank you for watching.